Marco's team merged a payments change at 2 in the morning, and the reviewer never looked at it. Nothing was broken. The reviewer works fine. It just sat there because nobody was awake to type into it. Every step of this system has quietly assumed the same thing. A person at the keyboard saying yes, freeze it there because a review that only happens while somebody's awake is exactly what this exam asks about. Nothing broke, so what has to change about where this review runs? That question lives in domain 3, configuring and running Claude Code, and it's a fifth of the whole exam. Call it roughly 12 of the 60 questions you'll sit. The guide splits the domain into 6 task statements. The previous episode took the first 3, and this one takes the rest. First, when to gate a change behind a plan instead of just letting it run. Second, what you actually do when a run comes back not quite right, and that one scored, not a pep talk. And third, how the reviewer runs with nobody watching, which is where the 2 in the morning merge gets fixed. The architect question parked in the corner all episode is the one the cold open asked. Where does the work run? Start with the vocabulary because items here name these modes and expect you to know which does what. There are 6 permission modes and the documentation names them default, accept edits, plan, auto, don't ask, and bypass permissions. Default reviews each action that would change something and asks you first. Accept edits pre-approves file edits and the common file system commands. Plan mode has Claude research and propose changes rather than make them, and it gets its own section. Auto mode puts a background classifier in front of the decision and it approves what passes its safety checks. Don't ask denies anything that wasn't already pre-approved instead of stopping to ask. And bypass permissions skips the checks altogether, which you do to a disposable container, not a laptop with live credentials. One naming trap. The mode written default in configuration is labeled manual in the interface and hooks still receive it as default. Same mode, 2 names. Match the string the question uses. One exception runs under all 6. A small set of read-only shell commands never prompts in any mode and the set isn't configurable. So an option claiming some mode stops Claude from reading the repository is describing a feature that doesn't exist. That's this episode's rule in miniature. If you can name the real mechanism, an invented one stops being tempting. Modes are the coarse dial. One layer down sits the single rule and rules hide a surprise. So here is how a single rule works. It names a tool and a specifier in brackets can narrow it to a path or a value. The order is fixed. Deny first, then ask, then allow, and the first match decides the outcome. Here is the surprise. How specific a rule is doesn't move it up that order. So a broad deny beats a precise allow every single time. One more is shaped exactly like an exam question. A repository can't hand itself the looser mode by writing it into the project settings file. Claude Code ignores that on purpose. The looser posture has to come from the user's own settings. A checked-in file that quietly widens what a run may do is the attack, so the product refuses to read it from there. Posture and rule say what a run may do. Next is the decision the objective names outright, plan the change or just make it. Plan mode first. Plan mode tells Claude to research and propose changes without making them, and edits stay blocked until you approve the plan. The guide is blunt about when that's right. Large-scale change, several valid approaches, architectural decisions, edits spanning many files. Direct execution is for the small, well-scoped change. One function, one validation check, a stack trace pointing at the line. So the test isn't how risky the change feels, it's whether you already know the shape of the answer. The guide even names a companion for the exploding part, the explore subagent. It keeps the noisy discovery out of the main conversation and hands back a summary. The guide publishes a question on exactly this. The stem, a monolith to restructure into microservices, dozens of files, boundaries undecided. One option says start executing and let the boundaries reveal themselves, which is how you find a dependency after you built around it. Another says write comprehensive instructions upfront, which assumes you already know the structure you're trying to discover. The third says start direct and switch to plan mode later. But the complexity isn't coming later, it's stated in the stem. So the answer is plan mode, entered first to explore and design before a single file is touched, because the shape wasn't known. One caution, because prep material overreaches right here, plan mode is a gate on your workflow. If the requirement is that something can never happen, you need a mechanism, a deny rule, or a hook that blocks the call. Then the plan's approved, the run happens, and it comes back not quite right. The middle objective looks soft on the list, and it's scored like the rest. Iterative refinement. The run came back not quite right, and what you do next has wrong answers in it. The guide calls the first technique the most effective. When prose keeps getting read differently, stop writing prose. Give it 2 or 3 concrete examples of the input and the output you want. Second, test-driven iteration. Write the tests first, covering the behavior you expect, the edge cases, and the performance you need. Then iterate by handing back the failures, a specific target instead of a vague complaint. Third, the interview pattern. Have it ask you questions before it implements, surfacing decisions you didn't know you were making. And one that shows up as a question more often than you'd expect. Several problems at once or one at a time. If the fixes interact, put them all in one detailed message, because repairing one alone will break another. If they're independent, go one at a time and keep each change small enough to tell what caused what. All of that still has you in the room. The next objective takes the chair away. Here is the mechanism for running it with nobody there, and it's one flag. Add -p or its long form print, and any Claude Code command runs non-interactively. It takes the prompt, does the work, writes the result to standard output, and exits. It exits 0 on success and non-zero on failure, the only thing a pipeline step really needs from it. The flags around it matter too. Output format takes text or JSON or stream.json for the events as they happen. The guide pairs the JSON output with a JSON scheme flag, so findings come back in a shape a script can post as inline comments. Allowed tools narrows what the run may call, permission mode sets its posture, and continue picks up where the last session stopped. And precedence matters. A command line flag outranks the project's settings file, so a pipeline sets its own posture at the call site. That's the flag in a shell script. The supported way in goes a step further. That way is an action Anthropic publishes, and it runs Claude Code inside the repository's own workflows. Mention Claude in a pull request comment, and it analyzes that code in the thread, makes changes, and can push commits. Or the workflow hands it a prompt, and it runs with nobody asking, which is the 2 in the morning case. A pipeline run has no you in it, so the project's instruction file is the only way that run learns your standards. Your testing standards, your fixtures, what your team counts as a finding worth raising. If it is not written down, that run does not have it. The session that wrote the code is worse at reviewing its own changes than a fresh, independent one. So the review always gets a run of its own. And that's every piece in place, which means it's time to sit the question this episode was built for. Here it is, straight from the guide's own continuous integration scenario. A pipeline script runs Claude with a prompt, asking it to analyze a pull request for security issues. The job hangs indefinitely. The logs say what Marco's logs would have said. Claude Code is waiting for interactive input. Name the question first, the way you have all episode. The prompt is fine and the tools are fine. What's wrong is where it's running, so this is where does the work run. Now watch what knowing the real mechanism does to 4 options. One option sets an environment variable that declares the run headless. Another adds a batch flag. Neither of those exists. They're not bad ideas you weigh and reject. They're features somebody invented for this question. If you can name the real mechanism, an invented one stops being tempting. The third option redirects standard input from dev null, the Unix reflex, and it silences the symptom instead of fixing the interface. The answer is the print flag add -p, and the run is non-interactive by design, which is precisely what the pipeline needed. Two invented features, one workaround, one real mechanism. That shape is the most common way this domain gets tested. Look at where the system stands tonight. It can tell planning a change from making one, it runs with nobody present, and it reviews every pull request in the pipeline. The 2 in the morning merge can't happen again because the review no longer waits for anyone awake. 2 lines to walk into the exam with. A run's posture comes from modes plus rules, and rules evaluate, deny, then ask, then allow. And if you can name the real mechanism, an invented one stops being tempting. Next time the reviewer starts flagging things that aren't problems, because a reviewer that cries wolf is its own kind of failure,